see everybody. My understanding is it's been going for a while yet. It's still pretty early for me. It's 10 in the morning, but good way to start my day. So as you can see on the title slide, this is No More SQLite, How to Write Tests with EF Core Using Test Containers. That QR code will take you to a blog post, which I think is not actually up. It will be up right after I finish this. But it will be a blog post where you can find these slides and the GitHub repo I use in this talk. And once the YouTube link is up later, I'll post it on that blog post as well. So if you want to see anything, if you scan that QR code, even in the post is not up yet, you'll at least have the link in your browser and you could refresh later if you want. And as you can see at the bottom of all these slides, it's just a reminder, you can find the slides in the repo at my blog. This QR code will be on the last slide as well. So we'll sort of get into what this title actually means. But first, real quick about me. I have been a software developer for about 10 years or so now, a consultant / coach for the last 4.5 of those years for a company called Lean Techniques. We do digital transformations. I'm a Microsoft MVP in .NET. I'm the co-organizer of the San Antonio / Austin .NET user group. Used to be 2 different groups before COVID. Now we're acting as one. And you can find me online, like I said, at my blog, mostly a .NET technical blog, daninAcan.com, or on X and LinkedIn, Daniel Ward Dev, on both of them, just with dashes on LinkedIn. So please hit me up if you enjoyed this talk, if you have feedback, if you hated it, whatever. It would be really cool to see people on there that saw me from this talk. So to explain what that title meant and to kind of kick this off, I want to start with a short general story that did happen to me, and I imagine has happened to others here, which is you're in charge of an API or service, some kind of app, and this app talks to a database. So might be it only reads from it, might be it does all the CRUD operations, whatever. But one way or another, your app needs to interact with the database, right? So like any good dev, right, you write a suite of tests as well. And integration tests are included in those. So this is always a question with databases and tests is how do we include those in our tests? Do we mock it out? Do we use SQLite? As I said in the title, what are the options there? And SQLite, I think, is probably the most common. It's at least what I always did before I found test containers. And this is what I did in this case. So I wrote a bunch of tests with SQLite, made sure the logic in my SQL queries worked as I expected it to, and everything passed. Everything's good. Everything's green. So it goes into production. And then wait, maybe it's a day, maybe it's a week, maybe it doesn't happen for a month. And this particular case, I don't remember exactly how long it was, but at some point, something in production fails. So I think, there's a case I forgot to cover. I didn't write all the tests I needed. So I go and poke around and see what it is. I say, oh, wait, no, I do have a test for that, and it's passing. So what's going on? And long story short, I think it took me 2 or 3 days to figure out what was going on because I had never encountered this before. I was using Postgres in production and SQLite in my tests, and I don't even remember what it was anymore, but there is some silly difference between these engines that for some reason it passes in my tests when it's on SQLite, and whatever it was worked a little differently on Postgres, and it failed in production. And so these are kind of this idea of these no man's lands where SQLite and Postgres or whatever engine you're using in production probably have a ton of overlap. I wouldn't be surprised if it's like 90% they work the same. But if you ever find yourself on either of these little outside areas, this no man's land, then you're gonna have a bad time. So it could be, depending on what it is, SQLite might have something. Your production one doesn't, right? They're just different engines. Or they might have the same feature, it just works a little differently. Or even worse, they might share different bugs. So you might have different behavior because there's a bug in Postgres that's not in SQLite. And I'm not saying you can't fix any of these. They're all fixable, but they're very frustrating to fix and very time consuming. You got to poke around and like probably end up in GitHub issues to figure out what's going on. It's just not obvious. So I call these false positives and false negatives, right? So false positives would be your test is passing, but really on your actual production engine, it would fail. But you can also have the opposite, right? Your test can fail, but really, maybe it didn't work on SQLite, but on Postgres, what your app is actually running on, it would be fine. And this is just as bad, right? Because it sends you down that rabbit hole still where you have to figure out what's going on. And so this is really the main point of this presentation. Before I even get to the demo, if you take away literally only one thing from this and forget everything else, then take away this slide. If you use a different SQL engine in your tests, you're testing a different system. It might be a really close system, but it's not the same one. So in my case, I was testing my system with SQLite rather than with Postgres, right? So you might say, well, maybe so, but they're really close. And, what else are we supposed to do? Why does that matter? Well, ultimately, the reason that matters is not really a trick question. It's the reason all of our testing matters, which is the bottom line, right? It's money. So if you don't have tests, you're probably going to have to do a lot of manual testing, which makes things take longer, which means you don't get value for your features as quick, right? So it's the same concept with this. If you have a very confusing failure, you have to, like in my case, it takes the developer 2 or 3 days to debug that, figure out what's going on. All of a sudden, that single test has become very expensive to fix, right? So we want to avoid that as much as possible. Like I mentioned, what are our other options? And I think this is an exhaustive list here. I think I've got them all, but let me know. And I think there are generally 4. One is the EF in-memory provider. Even Microsoft on their MSDN docs says, don't use this probably. So the pro of this, I think why people use it, is that it's easy to set up. The big con is that it's not even a relational database. It's very unlike your production engine. Then I think, like I said, I think the most common thing people choose is the SQLite provider. This has the same advantage of the in-memory provider. It's easy to use, but it's at least relational. It's close. It's still a relational database. Then maybe a step up from that is using an actual database out there somewhere that you've stood up, maybe in dev, maybe you have one for each environment. So the obvious advantage to that is that you can have Postgres or SQL Server or whatever you're actually using. The disadvantage is that it's basically, it's a maintenance nightmare. So you have to make sure whenever the actual database has schema changes, this test database gets them. You have to make sure this database doesn't go down. Since you're hitting a real database, only one person can run the test suite against it at the same time, or you'll have data conflicts. So that also means if the pipeline is running your tests, nobody local can run the tests, and they just have to be aware of that. And you can have services that you write to make sure that doesn't happen, but then you're maintaining another service. So it's possible. It has the advantage of being your real SQL engine, but it's a lot of overhead. So the next option here, last one, kind of, in my opinion, the best choice on here is to use Docker containers. You set up, in my case, a Postgres database in a Docker container, and you use that in your test. You spin it up when the tests start, and you run your test against it. Then you spin it down when the tests end. So it's still the same database as production, but it's all localized. You don't have any of the overhead of the row above it here. The one caveat here maybe is that there is still some maintenance to be done with a Docker container. Your team needs to know how to do Docker files, right? If nobody knows how to do that already, that can be a big overhead. And you also need to manage the container lifecycle throughout your tests. So you need to make sure you manage and be in control of starting it up, maintaining the connection, spinning it down, all that. So, and this is what some people were doing. And they said, this works, we like it, but we kind of do the same exact setup and stuff in all of our projects where we use these Docker containers. Can we kind of abstract this, make it easier to use so we don't have all this boilerplate, maybe automate it? And that's basically what Testcontainers is. They said we're testing. It was originally people in Java who were doing it. So Testcontainers came out for Java first, and it's been moved out to a lot of different languages from there. But they said, we're using these Docker containers in our tests and it works great, but we would like to make it a bit easier, remove some of the boilerplate. And they've added some additional tooling on top of that. So here's my test container slide just with the logo. On the left side, it had neither one of these is exhaustive, but on the left side here has some of the languages it's available for. Obviously, the one we're going to care about for this presentation is .NET, but the advantage of it being for a lot of different languages is that, if you switch where you're working and they're using a different language, you can still take that knowledge with you. Or if your organization is not all one language, you can still sort of post and help each other with test container specific things. And on the right side are some of what they call modules that people have written for it. In our case, we're going to be looking just at database stuff, but test containers can totally work with Kafka, RabbitMQ, MongoDB, so NoSQL stuff. It's basically whatever modules people have gone out and written. And if someone hasn't written a module, you can write it yourself. So the advantage of a module is that basically for each one of these services, you need some specific knowledge to know how to set that Docker file up, right? Every service is going to be different. RabbitMQ probably needs different environment variables and other stuff to set up that I don't know about. But somebody who does know about that has set that up already, so I can just plop that RabbitMQ test container in my project, and I can trust that it works. And this is just straight from their docs, very high overview level of how test containers works in your tests. So your test setup, you tell test containers, start my containers. When you run your tests, they now point to the connection string inside the test containers and hit the services in there. And on cleanup, your containers are destroyed. So pretty simple workflow. And just kind of to show you, the advantage of the in-memory provider and the SQLite provider is how easy they are to use. Well, this is basically what is required to use test containers, these 3 lines. So that first line will create it's telling test containers to give us a container, a PostgreSQL database in it. The second line starts that container, and the third line gets rid of it. And we actually don't even need the third line. I think it's good practice, but we'll go over that in the demo, that it's actually not required. Okay, so now I think probably the meat of this, the coding demo. I won't go over these other packages I'm using in the project, but in case you want to download the slides and look at these links so you can check out these other libraries, I've just included them here. So let's go over to Writer now. And this project will use Entity Framework Core, but actually test containers isn't tied to that at all. You can use Dapper, just maybe you're using ADO. It'll work with anything. It's just abstracting a database out, right? So there's nothing that couples it to EF Core. I think that's probably the most common option. So that's what I am centering this presentation around, but you don't have to. So if you saw my presentation from last year on XUnit, this is actually kind of a good segue into that. It's a similar project. I actually talked a very small amount about test containers at the end of that. So you can, that's just on JetBrains YouTube channel. You can check that out if you want. But it's a pretty darn simple project. We have an API project here. The idea is maybe we're a bookstore. We have a controller for that, right? So we only have 3 methods in our controller. This is really just for demonstration purposes, so we can have tests at all. So we can get a book. We can like a book, as in, I like this book, that kind of thing. And then we can have users review books. And really, these are all just pass-throughs into this book service that you can see. So let's go look at him. And these are mostly just pass-throughs to the DB context. So get book, very simple, just looks by name for the book. Like book and review book have a little bit of logic at them, which says, hey, if you're trying to like a book, you can't like a book more than once, right? You can only like it. You can like it, or maybe you can unlike it, but you can't like it twice. So we look for the book like record. And if it already exists, we don't fail, we just leave. We don't add another one. If it doesn't exist yet, we insert it. And the review book does the same, with the difference of that if the review exists already, we change the review content to be the new. Maybe they wanted to update their review, right, to be the new review content. Otherwise, we do a full insert. So that's the entire logic in our app. And we can look at the DB context too, which is also really simple. 3 tables. And here's one of our tables. As a side note, don't use this as an example of a good entity framework project. This was purely just so I could have a database out there to use in the tests. So as you can see, all I'm doing with these is slapping a primary key on them. So, okay. Now that's the really simple app we're going to be testing. And how you can see I have 3 integration test projects here. How I've kind of structured this is that they build on each other. So they kind of improve each time. So in the first project, I'll show the first stuff with test containers, and I'll say, here's how you can improve that, and go to the second one. And then here's how you can improve that even more. And then finally go to the third one. So with that being said, let's start with this first one. So we want to start in the integration test factory. And I'm not going to explain everything about how XUnit works here. But basically, every time we run these tests, we want a test container to start up, right? So in this initialize async here, we tell it to start a container. Well, where is this coming from? Just like I showed you on that slide, it's pretty darn simple. We say, hey, give me a PostgreSQL container. And it's a builder pattern. And there's a bunch of stuff you can add in here. So we can say, we give it a username and password. You can give it environment variables for the container. You can tell it what port to use. There's all these options. But the nice thing is we don't actually need to put any of them, because Testcontainers has this idea of sensible defaults. So if I hop over real quick to the source code for PostgreSQL Builder on the Testcontainers GitHub, you can see when I create one, these are all the things it will call, even if I do not give it any other things in the builder pattern, right? So it's going to have a username and password, a database. These things are going to be there no matter what. And these values, if I don't provide them, are actually up here at the top of the class, are these things. So these will be set no matter what. And I think this is fine, because in my test containers database, I probably don't care about the database name, about the username and password, right? The one thing I would say you probably should put is the database image version. It's because you want to be sure that matches the exact same version that you have in production, right? Not latest, not the default here. It's the exact same thing that you're using. And you want to make sure that gets updated whenever your database gets updated. The other thing to mention here is the port. You probably do not want to set the port yourself, because test containers, part of the tooling that it offers is that it will randomize the port each time, so you don't get port conflicts on your computer. So it takes care of that for you. So that being said, I could have done all this with username and with password, and it would have worked the exact same. But with just doing .build is really close to what I want anyway. Okay, so that's cool. I'm making a test containers container. In my initialize async, I say start it up. And for my database context that I'm going to use in my tests, the way I set that up is down here. So I remove the normal database context that we have, and then I add it back in using the connection string that I have for my container. And that's basically it. That's how I connect to the test containers database. And if you wanted to, you could even, put a breakpoint in here to see this connection string, and then go and log into that database yourself. It's a real database. It's just in a container, right? So I think that's pretty rare that you have to actually go look and poke around in your test database, but it's a real database, so the option is there. And then in my dispose async, I call dispose async on my container. Cool. So let's look and run an actual test. So this test is pretty darn simple. It just says, if there's a book in the database, I should get it back when I call get book. And that is the entire test. But so pretty simple, but useful for showing test container stuff. So I'm going to put a breakpoint here and debug it and pull up Docker desktop. And I should note, you will need Docker on whatever machine this is running on, because this will spin up an actual Docker container. Okay. So we've hit my breakpoint here, and notice test containers. Here's my test containers. But you might notice it's created 2 of them, and we only asked it for the Postgres one, right? So, but we also got this other thing, this reute container. So what's that about? And before I explain that, I'll just let the test finish to show it passes, I suppose. Except when it doesn't pass. Oh, it did pass. I was looking at my previous runs were failures, which these should be failures. We'll get to that in a second. But my get book test pass. So what was with that reute container? Well, every time you run test containers, it will spin up implicitly this thing called the reute container, which is what it calls the resource reaper container. And it's called that because it is in charge of making sure all the other test containers get spun down, and then it disposes of itself. So if you're wondering, yes, it is named after the Death Note reute because it's the resource reaper. And this is not a big deal. I just thought it was kind of cool. This is kind of funny. If we go to the GitHub source code for the reute container, the way it works is basically it keeps a dictionary of all the test containers that it needs to delete, and it calls that dictionary the Death Note. So that is not of any consequence. I just thought that was kind of cute. But anyway, the way this guy works is when you run your tests, it starts the reute container, and the reute container opens up a TCP connection to your .NET process. So when the tests finish and that .NET process closes, Ryuk, actually the first thing he does is he tries to reach back out. He says, did the connection actually get severed, or is there a network issue? If he doesn't get the TCP connection back in a few seconds, he says, all right, time to shut it down. And he closes all the other test containers. So the nice thing about this is, even if .NET process crashes, writer crashes, something happens and your .NET process doesn't actually get to shut down, it doesn't matter. The reute container will still lose its TCP connection, and so your containers will still get spun down. So this is a big part of that. Can we provide tooling that automates this boilerplate stuff we're doing? So they've included this in test containers, so you don't have to write this yourself. Cool. Now, next, let's look at the likebook tests. So there's only 2 tests in here. Also pretty simple. And they're kind of the inverse cases of each other. One says, when this book like record doesn't exist in the database yet, and then they try to like a book. Here.
Daniel, I think we lost your audio.
Am I back?
Yep, you're back now.
I saw my
leave.
camera spinning. I don't know what happened there. Sorry.
Yep, no worries.
Okay, cool. So I don't know where I cut out, but there's 2 tests in here. They're pretty simple. One says if we have not liked this book yet, and we call the book like method, then there should be a book like record in the database afterwards. The other one is the opposite. It says if we've already liked this book, and then we call the book like method, then we shouldn't have 2 records. We should just still have 1, right? So let's run, instead of just running one of these, let's run both of these and see what happens. The previous run is kind of giving it away here, but okay. So one of them passed, one of them failed, right? So the one that passed was the book like exists in the database already, and the one that failed was it doesn't exist yet. Does anyone know why one of them passed and one of them didn't? And the reason is we had essentially we had state bleed between our tests. They're both hitting the same database. So this guy says when the book like exists in the database already, so to achieve that state, he inserts a book like first, right? And then he calls the method. So that passed. Well, and this guy said his state is the book like shouldn't exist in the database yet, right? So the state from the test that ran first bled into the state for the second test. So now we have another problem, which is going to exist whether you have test containers or not. But this problem is how do we manage states between test runs in it when we're using a database? Because that database is acting as like a centralized data source, right? So basically, we probably want to reset our state back to some kind of baseline between test runs. The problem is we want to do that in a fast way. And messing with SQL and databases is kind of inherently not fast. So what can we do for that? And I could run these. I'll run these book review tests as well. But it's the exact same problem as the like book tests where one of the states for one test bleeds into the other one and messes it up. So one of them passed and one of them failed. So to see that, let's go into our second integration test project here. Okay. And we're not going to change anything actually with test containers in this. We're going to introduce another library, and that's called Respawn. Respawn was written by Jimmy Bogard, who's the same guy who wrote AutoMapper and Mediator, if you're familiar with those. And I didn't see this anywhere in the README for Respawn, but I suspect it was made specifically to work with test containers. I don't know if there's anything that couples it to that, but it seems like they're kind of made for each other. So Respawner, the only job Respawner has is to reset a database back to a clean slate by deleting rows. That's the only thing this library does. So this is pretty simple as well. I create a respawner. I define my respawner up here, and I create it. Same thing in my initialize async for my integration test factory, which is the same spot I'm starting my container, right? And I create it with this respawner.create async method. I need to have the container connection string by this point, so I have that. I tell it I'm using Postgres. There's a few options here. There might be other ways to put options that you don't see here into this, but I usually use Postgres, so I just haven't worried about that. And then you give it the schemas to include. These are the schemas it will delete. In our case, we only have one schema. It's called public, so we just give it that. You can also give it schemas to exclude, tables to ignore, things like that. And really, the nitty gritty of how this works is not important, but in the README, he says, for speed, for performance reasons, I don't use truncates. It uses foreign keys to create this like dependency graph of your database, and it uses deletes on all your tables because apparently deletes are faster. So that's already beyond my my realm of knowledge, but the proof is in the pudding. I suppose we'll see this running in our tests and how long it takes. So to actually use this in our tests, I now have this public method on our integration test factory called reset database. And all he does is called respawner.reset async. And that's what tells Respawner, hey, go out and delete stuff. All right. So now let's look at our like book tests. And which is now inheriting from iasync lifetime. So I get this dispose async method where I call reset database, right? So this means after every single test run, it's going to wipe out what I have in my database. And you could combine this with a common set of records that you seed your database with, or maybe each test seeds it with its own unique records. I think that'd be fine because from my own testing, this does still seem to be quite performant. So these are the same tests. I didn't change anything in them. They just have the respawn or reset async in them, reset database in it now. So let's just run the whole class again. They passed. I will say from running test containers myself, depending on your machine and how much stuff you have running on it, which I've got quite a lot on it right now because I'm sharing in PowerPoint and Writer and all that. There seems to be like a one-time 3 to 5 second overhead for test containers, something like that. So, okay. I also want to point out, so these work now because of Respawner. Let's run the entire integration test 2 test suite, not just the class. Actually, let's put a breakpoint so we can see. We don't need the breakpoint. We can see it still. And let's just open up Docker here. So here's Ryuk. And you can see it's created 3 Postgres containers, right? And this will make sense if you know how XUnit works. I just wanted to say this explicitly because I think it's an important point. He'll close himself down. He usually just takes several seconds. There he goes. Waiting for that connection, right? Actually, that wouldn't be waiting for the connection because he already closed all the other containers down. I suppose he just takes a few seconds. So the reason it created 3 Postgres containers, this is more of a XUnit thing than a test containers thing, but still noteworthy, is because I'm using class fixtures with Integration Test Factory. So this means I get 1 Integration Test Factory created for every class fixture I have. And this is better than the default behavior, which is it would create a test container for every single test that I have, right? I have 3 class fixtures because each one of these is its own class fixture, right? So each one of these is using its own separate Postgres database. Now, that may not be what you want for your use case. It just depends on what you're doing, right? You may decide to split it up for performance reasons. You may decide to split it up for table conflict reasons. I don't know. But you have options there, right? And your third option is XUnit's database, not database, collection fixture. So this is kind of a step up from class fixtures. Class fixtures says 1 for the whole class. Well, collections, you just slap on any class you want, and classes can share the same collection. And then you'll have 1 container for that whole collection. So you may decide that makes sense for you. You may say, well, my tests run faster if they're in 3 containers instead of 1, right? And I don't mind the resources that takes up. But that is that just pointed out, it should be a conscious decision on your part, right? To be aware of that. So this third project here, I kind of showed one of these files already. This third project doesn't change a whole lot, but I did 2 main things. One, I cleaned things up a little bit. So what I think is more good practice that I like to see in integration tests. So one of those is this abstract database test class that has stuff that probably all or most of my database tests are going to need. So they're all going to need the DB context. They're all going to need the reset database method, the HTTP client. And then I added some helper methods in here for them to call to insert stuff into the database. And now all my tests inherit from that database test instead, right? So that's one thing. The other thing is I kind of wanted to show the performance of test containers and Respawn. So I did something very technical and copied and pasted the same couple tests over and over and over and over in these 2 files. Okay. So I think there's like 52 tests in each file or something, just to show how they run. And in this second lots of tests, I'm also testing Respawner. So I'm telling it to, in this case, insert 100 books into the database and delete them between every single test run. Okay. And see how that runs. We could probably even bump that up. But let's run first. Let's just run this lots of tests 1 first and see what happens here. Let's close these 2 up. And nothing in these should fail. I just am mostly interested in how long it takes, right? So this says a little over a second. This whole thing says a little over 4 seconds. That's probably because of the overhead. Actually, I believe this is cumulative. It's adding these up. So it's just a little over a second for those, about 52 tests, standing up test containers. Maybe your writer's warm now, or test containers is warm now. I don't know. It's starting up pretty fast. Let's run lots of tests. You know what? Let's bump this up to 1,000. So we're inserting 1,000 books and deleting those between every single test. And let's see how long that takes. And I will sort of spoiler. I ran this myself on my desktop with 10,000. Obviously, this is while I was not, sharing my screen. I had more resources on my computer, and it took about a minute. I think it was a minute and 7 seconds. So that's inserting and then deleting 10,000 rows between each test. And you can see for 1,000, it was about 8.5 seconds. Now, even with that, I would say if you're having to insert and delete 1,000 rows between each test, maybe performant. Maybe that means you might want to rethink your test suite structure a little bit, split those out potentially. But, just to show this can handle it. Also, admittedly, this is a pretty simple insert and delete. It's just one table. But I think with 10,000 rows a minute and 7 seconds, that's pretty good. So let's run the whole suite, number 3 suite. Pull up the, sort of see them both here. Pull up our Docker desktop window. And you can see we only have 2 Postgres SQL containers. And that's because I've created 2 of these collections, these Xfixture collections. One is database test collection. I think it is called the other one database test collection 2. Yeah. And all of my classes I have tagged with one of those. So there's only 2 collections in my whole test suite in this third project. Therefore, I only get 2 PostgreSQL containers. So maybe that's more applicable to your use case. It just depends. Again, good to be aware of. So I believe that concludes the coding demo. We can go back to a few more slides on the PowerPoint and then take questions. So honorable mentions, there's only 2 things on here. These are things that I was like, it didn't make it to the demo because maybe it's not fully fleshed out yet, but I thought it was worth mentioning. One is this thing called a resource reuse. It's also sometimes called reusable containers. And the way you enable this is just, I'll go back into my writer here. In your Testcontainers builder, you just say with reuse true. That's it. And if this is true, which is false by default, it will look at the configuration you have for this container, make a hash from that configuration, and then it won't spin down the container when your tests finish. And instead, whenever you try to create a new container here, it will look for that hash first. And if it's the same hash, it just refers to that existing container. So I have not had a use case where I don't want, I'm fine with spinning down my containers between tests and then between test suite runs and then putting them back up. But, if you have a use case where for whatever reason you want to keep those containers around, that's available. Now, this is a beta feature still. It's experimental. I think in the docs, it says it doesn't get 100% of the config options into the hash, but it is out there to try out. And the other thing is Podman. So maybe about a year ago, Docker made some pricing changes that were, let's say, a big change for a lot of enterprises. So I think when that happened, there was a bigger push to go to Podman, which is just a free version of the Docker API, basically. And in theory, Testcontainers is not coupled to Docker. It works with any Docker-compatible API, which Podman is. In practice, every language version of Testcontainers has different maintainers. So the people who do the .NET Testcontainers are not the same people who do the Java ones and the Go ones and etc. So, for instance, I know that Go does have full official support for Podman, but .NET doesn't. But I've also looked around online a little bit and seen a couple of people say, I've used it with WSL instead of an environment variable, and it worked just fine. So I can't vouch for that personally, so I won't say it works. But I think that option is out there if you want to look into that book round. And I like to recap stuff very briefly in bullet points at the end of my talk, because sometimes I leave a talk and all that information leaves my brain too. So we went over those 4 traditional options that you usually see, I think, for integration testing with the database, right? The in-memory provider, the SQLite provider, a real test database somewhere, and then using Docker containers. We went over what Testcontainers is, and the benefits it has over those other 4 options. We had all the stuff in the coding demo. We saw how Testcontainers works, how you create it and spin it down, get the connection string, how your tests, how running your tests will spin up the reute container and your the actual containers you asked for. We saw how respawner worked, and we saw kind of some performance testing with Testcontainers and Respawn. And as a side note, I would not, in general, I don't think Testcontainers is a load testing tool. I think that should be done on your actual servers, right? All we really care about is if our tests run fast. It's not really a good test for if our actual app will run fast, in my opinion. Right? I think that should be done on your actual the actual app. Like I said, we saw Respawn, the library from Jimmy Bogard, that will quickly reset our databases for us. And that's it. So like I said, here's that QR code again for my blog post that will be up right after this. That has these slides in the GitHub repo I used on this. And there is a link to my blog, daninacan.com. And again, hit me up on the socials. Would love to see some of y'all. And I think I might actually be a little early even, but I'm happy to take questions. So.
All right. There are several questions. So Rachel, ask the first question. You go ahead.
Okay, I'll start with the beginning. And because Khalid also noticed this, I could see the light bulb going off. Like when you said, if you use a different SQL engine, you're testing a different system. I feel like you say this and it seems obvious once it's come out of your mouth, but it's not. It's really, a lot of people don't seem to actually get that. They go, well, we have Postgres here in production and I'll just test against SQLite or something else. It's not the same because of those little database quirks and stuff, right? And more, right?
Yeah, and I totally agree with you, because SQLite is what I used for I don't know how many years, because that was just the best option that I knew about, right? And maybe at the time Testcontainers wasn't available in .NET for all I know, but I think it was just the best bang for my buck. Maybe like there was no easy way to get Postgres or whatever SQL Server, whatever you're using, running in your tests, like to spin that up and down quickly every time, that I knew about at least.
Yeah, and you kind of hinted at it, like you start to get these false positives, right? You get this false sense of security and confidence. It's like, hey, we tested this, goes into production. Maybe the SQL syntax changes, maybe features change, maybe implementations change. You just don't have a good sense. So, Daniel, just to kind of tell you, we did run a poll.
Okay.
Which method have you used most in the past, tests involving databases? So the options that we gave are chat, real databases, in-memory provider, Docker container, and your beloved SQLite provider. I'm just joking with you.
Did that one win?
No, actually it didn't. So real databases come in at 36%. So it seems like folks kind of understand this.
Okay.
Yeah, it's pretty good. Coming in
production.
Yeah, hopefully not in production. Do not test in production, people. Second place is in-memory provider. So maybe, I think that really comes from the fact of like, maybe people want tests to be fast, but fast and wrong isn't really a good option. So
you're just wrong faster.
you said like when your tests fail and you lose confidence, that's maybe the worst thing about it, is that once that happens to you once, you, at least for me, I was like, well, now I don't know if any of my tests are working really. Like they could be false positives now. I don't know.
Yeah. Yeah. It's just kind of the worst place to be, right? So Docker containers comes in at third place at 24%. So it seems like a good portion of our audience is already kind of on this.
Pretty good.
Yeah, it's really good. Like it's on this train of like Docker's there. It's very useful and it kind of gets me the dependencies that I want. So that's good. And then you're going to break the heart of this other 11%, but SQLite provider users. But who knows? Maybe they're shipping SQLite to production. Maybe they're shipping it to production. Who knows?
I was going to say, this is all kind of assuming you're not using SQLite for your real data. Maybe you are, you know?
Yeah, it's totally.
It's out there.
That. I haven't done that, but I'm sure there's use cases.
There's SQL Express out in production. There's going to be SQLite in production.
Yeah. Well, I think SQLite has 3 terabyte limit, so you can have a 3 terabyte file of like a SQLite file.
Oh,
so
interesting. Okay.
Yeah,
and I believe there is actually a SQLite module for test containers anyway. Yeah. And that reminds me, I was just going to show this page. Here's the .NET modules on their website, just to show you. These are the ones that are already out there.
Mm-hmm.
So quite a few, and this definitely not all databases.
Into the next question, which is if you've considered building your own container images to speed up test performance, or are you just using off the shelf?
I'm definitely just using test containers. Writing Docker files for me kind of falls into the same place as writing regex, which is that I have to learn how it works every single time I use it, like look up docs every time. So
not just me.
The less I have to do that.
About that.
Yeah.
Yeah, I mean, I understand the value of Docker, but actually sitting down to try to do anything with it is just a giant fight, right? And then you don't do it unless you're in DevOps or something, obviously.
And I'm sure there's some people who do write them a lot, and they're really good at it. And maybe they're the people who have wrote these modules, you know?
Right, right.
Better them than me.
Well, you know, the interesting thing about that question, when you were running that test where you were inserting and deleting all those records, I imagine if folks have really large schemas with a lot of lookup tables and a lot of kind of static data, let's say you have like zip code information or addresses or something like that that doesn't change, it's read-only. I could see building a container that specifically has databases that are preloaded with that information. That could definitely speed up your tests, so you don't have to worry about kind of rebuilding those databases over and over again. So,
and if it's possible, you can tell responder to ignore those tables, right? If you're not doing
very true, very true. Yeah. You did hint at that reuse functionality. So if building and tearing down those containers is kind of your bottleneck, maybe consider that as well. So that was kind of cool. Rachel, any other questions?
Yeah, another good segue from there, since you brought up respawning. One of the questions was, why is it better to use respawner than a single container for each test?
Than a single what?
Why is it better to use a respawner than a single container for each test? Although single container for each test seems like a bit, but why better a respawner
use a single container for each test? You can do that. I don't know how far you'll get with that before your computer shuts down, but you can. Maybe they're super light and it works, but.
Yeah. Well, let me ask you a question that's kind of related to that. You know, you were running your tests with Respawn, and like, does that exclude the ability to essentially run your tests in parallel, or is that something you kind of have to think about before you kind of write your tests?
I'd say in general, you can still run them in parallel, but it's still something to think about, like how you structured your XUnit collections with how many containers you're making. Like maybe with Respawner, you could run everything in parallel because you're wiping it out. But maybe if you split it out into 3 containers instead, you wouldn't have to wipe it out anymore because the tables are separate. Mm-hmm. You can also get dirty with that really fast and how your test suite is structured.
Well, let me ask you something personally, like for you and your team, like who's responsible kind of for maintaining the health of your test suite? Because, you could easily get out of control where you're generating a bunch of containers for each specific test. But how often do you and your team go in, reevaluate our test running fast enough? Do we need to kind of change anything? Like, what kind of advice can you give our audience?
Yeah, I would say in general, like I'm coaching a lot of teams right now and not
Mhm.
doing dev work with them, but in general, um, especially when I'm coding with them, everybody is responsible for the test suite. If a change gets into main, that's everybody's responsibility. If we had PRs, what we said as a team norm was that the person who approved it was just as responsible as the person who wrote it. And that usually gets people pretty quick. Um, but the test suite is the whole team should own that. And in terms of speed, um, I think that's a hard question to give a number to. Like when are the tests running too slow? But I would say in general, if my test suite is taking longer than 15 minutes, I'm going to poke around and look at stuff because at that
Mhm.
point, I feel like it. If you've heard long enough for me to get up and go get a cup of coffee, but short enough to be done by the time I get back. So if it takes longer than that, like I get taken out of it. Like my brain starts doing other things. But I
Yeah,
also don't expect it to be immediate either. So
I think that's a good rule of thumb. It's like, I guess you're saying like a good enough feedback loop where you can kind of submit work, see it, provide value, and then you can kind of interact on it. So, like, I
yeah,
know a lot of folks probably do some of their major testing overnight, and those feedback loops can kind of feel a little slow. So, finding and fine tuning that time is pretty valuable. So, here's another question for you. Is there a specific cost to using test containers? So, you talked about the money factor earlier. Does test containers cost anything? What should folks think about when adopting test containers?
that's a good question because I don't think I said it. Testcontainers is open source, free. Docker is very much not free, obviously. Which is I made the Podman point.
Yep.
So I would like in a future version of this to be able to show Podman stuff, but like I said, it's not like the .NET version of test containers does not have official support for Podman right now. That would
Mhm.
be the biggest cost, in my opinion. I think your cost goes down by using test containers, if anything. I don't think
Okay.
there's really much overhead, and they're saying the library. It's pretty quick. I
Yep.
think it would mainly be the other tooling costs that it uses.
Yeah, and the follow-up to that was how hard is it to set up locally? I think it's just install Docker for
You got to
desktop
have
and
Docker
run
installed.
it.
Yep,
Yep.
that's it. And
Uh,
running, installed and running.
yep. I always shut down my Docker daemon, and I'm like, "Why isn't this working anymore?" And then I realize, "Oh,
I've done
yeah, I
that many
turned this on."
times. Yeah.
Do it all the time.
Rachel, there's one more question in chat, and then I guess we could wrap up. But do you want to go ahead and ask it, or?
Yeah. Did we ask them what unit testing framework is best suited?
Um, I guess Daniel likes XUnit, but do you find test containers works with any unit testing
I mean,
framework?
Well,
right. It
it
should
didn't
work with
matter.
any of them, right?
Yeah, XUnit
Yeah.
is what I'm most familiar with and what I was able to talk best about. So I use that, but it doesn't matter.
Okay.
The only other thing I think we didn't ask is somebody asked if we can use test containers plus respawn with raw SQL.
With what? Sorry.
Raw SQL. So I guess just
Yeah.
SQL,
I mean,
right?
as long
Okay.
as you're getting stuff, as long as your code is interacting with the database. I mean, test containers doesn't care how it got there. It's just putting the database
Right.
out there. So you can use EF Core, Dapper, raw SQL, ADO.NET, whatever.
Yep. We do have one more question that came in. You kind of hinted at this, but like, how do test containers integrate with build pipelines? So whether you're using GitHub Actions, TeamCity, or some other CI/CD solution.
I think the only big difference with that would be that this again, you need Docker running in whatever is running the tests.
Mhm.
So that's true for the pipeline as well.
Yeah, and I'm pretty sure GitHub Actions VMs have Docker
I
enabled by
I,
default.
I
So
think I think they do.
Yep. So on that note, I think we're out of questions. Daniel, this was an awesome talk. I loved it.
I do want to say one thing, which is that last year after my X unit presentation, I saw Cal made a blog post about test containers shortly after that. So I just want to say I accept royalties.
All right. I'll send you the check.
I'm not making any accusations, but
one more thing. Daniel has to, go and do that. You get a test container and you get a test container.
Yeah. I should have stickers here. I can just throw them.
I will say you did inspire me, Daniel. So it's a good eye that you caught that. And I
actually thought your post was much more in depth than what I talked about. So
no,
I learned stuff from your post. So.
Come on, Daniel. You inspired me to write it, so I give you 100% of the credit. I'll be sending you all the royalties that I get from writing blog posts here at JetBrains, which is $0.
Glad to hear. Okay. Cool.
But on that note, thank you. We'd love to have you back. This was a great talk, and we'll catch you next time. So
cool. Thanks for having me here.